Now we discuss the topic that is torque or moment of force. What is the moment of force or torque? When an external force acting on a body tends to rotate that body about an axis. This tendency is called moment of force or torque. Here we take the example of the wheel. This is the axle of the wheel. This is axle of the wheel. If we apply the force on the axle of the wheel, so here we write that force acting at axle of the wheel is not able to create any torque. So here is the torque is equal to 0. Now we discuss the another force that is acting on the wheel but is now not is acting on the axle. This is also the wheel. This is the axle of the wheel. Now the force is acting on the this direction of the wheel. This force is able to rotate the wheel. This is the distance r from the axle. So this force is able to rotate the wheel. So here we write that force acting at radius r gives a torque. So torque is equal to r into force F. This is about the torque or moment of force, how we produce the torque. Now we discuss the force is acting at an angle theta with respect to the position vector r if the applied force F act at an angle theta with respect to the position vector r. Then here we write that this is any rod and here we apply the force F at an angle theta. This is the force F and this is the position vector r. Now the force F is not perpendicular to the position vector r. We draw a component. We resolve the force F into two components, F cos theta and F sin theta. Now the component of the force F sin theta is responsible to rotate the rod. So this is the able to rotate the rod. So we have to write that. So the component of force F sin theta is responsible to produce the rotation. So torque formula becomes torque is equal to magnitude of position vector r and the component of the force F sin theta. So torque is equal to r F sin theta. That is the formula of the torque when the force F is acting at angle theta. Now we discuss the another case. If the applied force F act at an angle theta with respect to the position vector r, then here we take the position vector r and let's suppose this is the force F is acting at an angle theta with the position vector r. Now we resolve the component force. Now we resolve position vector r into two components. So this is the r component is r sin theta. So this component of r sin theta is responsible to rotate the body. So the component of vector r is r sin theta is responsible to produce rotation. So the formula becomes magnitude of the force F and the component of position vector r is r sine theta is responsible for the produce the torque. So its torque is equal to rf sine theta. So here we discuss another case to produce the torque. Now we discuss the maximum torque. Torque will be maximum when angle between R and F is 90 degree or to 70 degree. So torque maximum is equal to R F sine 90 degree. So sine 90 degree is equal to 1. So torque maximum is equal to R into F. This is the torque is maximum when the angle between position vector R and F is 90 degree or to 70 degree. Now we discuss the minimum torque. Torque will be minimum when angle between R and F is 0 degree or 180 degree. It is only possible R and F is parallel, so angle is 0 degree. Here we discuss the position vector R and force F. If these are parallel, then the angle is 0 degree. So torque is equal to R F sine 0 degree, that is equal to 0. So torque is 0. And if R and F is anti-parallel, this is the force F and this is the position vector R. These are the make an angle of 180 degree. So here the torque is equal to R F sine of 180 degree, that is also is equal to 0. Now we discuss the factor on which the torque depend. Factors on which torque depends. First one is magnitude of applied force F. Second one is magnitude of position vector R. Third one is angle between applied force and position vector theta. So here we write the formula of the torque, that is equal to Rf sine theta. Three factor which the torque is depend.